This is question 1 for WASSCE 2012 November Mathematics Paper 2. X and Y are subsets of U such that U is equal to integers from 10 to 20. X is equal to the set such that X is greater than or equal to 10 but less than 50, and Y is equal to even numbers less than 18. Find A, X intersection Y, B, X prime intersection Y, C, Y union X prime intersection Y prime. So let's see how we go about all this. So let us first list the elements of the universal set, which are 10, 11, 10, 11, then 12, 13, 14, 15, 16, 17, 18, 19, and 20. The element of X are, we start from 10 inclusive, then we have 11, then we have 12, 13, 14, 15 is not included. So these are the elements of X. Now the even numbers that are less than 18, because the universal set starts from 10, we begin from 10, then the next even number is 12, then we have 14, and then 16, but it must be less than 18, so 16 is the last one. Then now let's look at the first part of the question. We are supposed to find A intersection X, which is elements that are in both sets, common to both sets. So X intersection Y, we have 10, that is common to both sides, that is both sets. Then 12 also is common to both sets. Then 14 is common to both sets. So this is X intersection Y. Then we now move on to the B part. For the B part, we are supposed to find number of elements in X prime intersection Y prime. So first we need to list the element of X prime. So the element of X prime are elements that are not in X but they are in the universal set. So elements in the universal set that are not in X. So these elements are 15, 16, 17, 18, 19, 20. So let's write them down. X complement or X prime is equal to 15, 16, 17, 18, 19, and 20. So these are the elements of X prime. Now we want to find X prime intersection Y, element that is common to both X prime and Y. So these elements are 16, so only 16. So the number of elements is only 1. So this implies that the number of elements in X prime intersection Y is equal to 1. Now let's proceed to the C aspect. For the C aspect, we are supposed to find Y union X prime intersection Y prime. So let's find Y prime since we have X prime already. So Y prime will be equal to elements that are not in Y but they can be found in the universal set. These are 11, 13, 15, 17, 18, 19, 20. So let's list those elements of y prime or y complement. There are 11. Then we have 13. Then we have 15, then 17, then 18, 19, and 20. So let's find x prime intersection y prime. So elements common to both sets. Element common to both x prime and y prime. They are 15, 16, then we have 17, then 18, 19, 20. So these are all common to both sets. So we have 15, then we also have 17, we have 18, we have 19, then 20. Now the union of set y and x prime intersection y prime will be elements that are in both sets. The elements that are in y or x prime intersection y prime or both. So element in y or x prime intersection y prime or both. So these are 10, 12, 14, then we have 15, we have 16, then we have 17, then 18, then 19, and 20. So these are the elements. We want to look at the question 2. We want to factorize completely 9a squared minus 4 into a minus b all squared. We need to rewrite this as difference of two squares. That is 9a squared is the same as 3a all squared, and this one is the same as 2 times a minus b all squared, because 2 squared is 4. Now what we need to do is to use the difference of two squares formula. If we have x squared minus y squared, this is the same as x plus y into x minus y. So we are going to use this relation, and in our case we realize that the 3a is equal to x and the y is equal to 2 into a minus b. So this will give us 3a into 2 into bracket a minus b, that is 3a plus that, and we also have 3a minus 2 into bracket a minus b. So this is supposed to be minus. Now we can simplify by expanding within the parentheses. So we have 3a plus 2a, then 2b minus 2b. Then we have 3a here, negative 2 times a will give us negative 2a, then negative 2 times b will give you positive 2b. So we now have to simplify. 3a plus 2a will give us 5a, and this will give us negative 2b. Then also we have 3a minus 2a, which is a, plus 2b. So that's it. Now let's look at the b part. The number is written as 14 base n. If 3 times the number is equal to 45 base n, find the value of n. So 14 base n times 3 will be equal to 45 base n. Now let's convert all of them into base 10. So we have 1 times n exponent 1, 1 times n exponent 1 plus 4 times n exponent 0 will be equal to 4 times n exponent 1 plus 5 times n exponent 0. So this is how we convert to base 10. Now this will give us 1 times n, because n exponent 1 is the same as n, then n exponent 0 is the same as 1. Then we have 4 times n plus 5 times 1. So let's simplify within the parentheses further. We get n plus 4 is equal to 4n plus 5. We can now expand on the left to get 3n, then 3, 4, 12 will be equal to 4n plus 5. Now the next thing we do is to group like terms. So we have 3n minus 4n is equal to 5 minus 12. And that will give us negative n equal negative 7, which implies that our n is equal to 7. Let us now look at the third question. In the diagram, MNOP is a rhombus and PQNO is a kite. Angle PMN is 76 and angle PQN is 120. So calculate the size of angle QPO. Now we can recall that the opposite angles of a rhombus are equal. So that is also 75. Then angle PMN will be equal to angle PON, and that will be equal to 76 degrees since opposite angles are equal for the rhombus, and these two angles for the kite are equal. Therefore, we have angle PQN plus angle QNO plus 120 degrees plus the 76 degrees equal 360. This is the sum of angles in a quadrilateral. Now let's simplify. Because the two angles are equal, PQN equal QNO. Whatever we see QNO, we can put PQN. So PQN plus PQN, then plus 196, which is 120 plus 76, will be equal to 360 degrees. Now let's simplify. 2 times of angle PQN will be equal to 360 minus 196. Now let's subtract to obtain 2 times of angle PQN to be equal to 164. So divide both sides by angle PQN to get 164 divided by 2, and that will be equal to 82 degrees. Now let's look at the B part. In the diagram, triangle PQS is a right angle triangle at Q, and PQ is 5 centimeters, angle SPR equal Y, and PS equal 8. We are supposed to find angle Y. We know that the cosine of angle QPS will be equal to adjacent over hypotenuse, which is 5 over 8. Then we can simplify this by taking the cos inverse of both sides to get angle QPS to be equal to cosine inverse of, so angle QPS will be equal to cosine inverse of 5 over 4, which is 51 degrees. 5 over 8, which is 51 degrees. Now we can sum the angles in the triangle to get 180. So we have that angle QPS plus the 90 degrees angle. Okay, plus the 90 degrees angle plus this angle over here, which is 90 minus 51. 90 minus 51. Then it should be equal to 180. Yeah. So we know that this angle will be 38 because that will be 90 minus 52. So the angle QPS is Y plus 38. Then plus the 180, which is 90 plus 90 minus 51 is equal to 180. Now the 180s will cancel, then 38 minus 51 will give us 13. So this means that we have y minus 13 equals 0, and that means that y is equal to 13. This is question 4. Let's look at how we go about it. In the diagram, PQR is a semicircle. If PQ is equal to 16 centimeters and QR is equal to 12 centimeters, and figures the radius of the circle, the area of the shaded part. So let's look at how we can solve this question. We want to calculate the radius for the A aspect, and we know PR is the diameter and PQ and QR meet at 90 degrees. So from the right angle triangle, using Pythagoras theorem, we have PR squared is equal to PQ squared, which is 16 squared, plus 12 squared. Now we can simplify. So we add 16 squared to 12 squared. But for that 16 squared, before that 15 squared gives us 256, and 12 squared gives us 144. Now if we add the two, we get 400. So PR squared is equal to 400. Sorry, this is supposed to be 4. So PR squared is equal to 400. Now let's take positive square root of both sides to get square root of 400, and that will give us 20 centimeters. But PR is the diameter, so the radius is half of the diameter, which is 20 over 2, and that will be equal to 10 centimeters to 3 significant figures. Now the B part, we are supposed to calculate the area of the shaded part. So that will be equal to the area of semicircle minus area of triangle, which is the right angle triangle. So area of semicircle will be equal to half BH. Sorry, area of semicircle will be half pi r squared rather. So area of semicircle is half pi r squared, and that will be equal to half of 22 over 7 times the radius, which is 10 squared, and that will be equal to 157.1429 centimeters squared. So we found the area for the semicircle. Now let's find the area of the triangle. So area of triangle PQR. Area of triangle PQR is equal to half base times height. Half base times height, and that will be equal to half times the base, which is 12, times the height, which is 16, and that will give us 96 centimeters squared. So the next thing we do now is to subtract. So area of shaded part will be equal to area of semicircle, which is 157.14 minus 96, and when we do the subtraction, this will give us 61.14. you need to correct to 3 significant figures, which is 61.1 centimeters squared.